right, the second question on 2013 was a one-dimensional array, and it was this token pass, little game, kind of like the game Man Colin, if you ever played that. So there's a couple of rules. We're going to have to randomly assign tokens to all the places on the board, at least one, no more than 10. So classic math.random there, something that we've practiced a lot. We also have to randomly choose a player. Every player in the game should be given one place on the board. So like if the board is length 8, then there's 8 players. If the board's length 2, there's only 2 players, and so on. And then we have to randomly choose one of them, giving everybody an equal chance. Okay, so it'll be another random int generator. However, this one's going to start at 0 and just depend on how big the board is. And we'll do that in part A. And then here's some rules for part B, this bullet point list. Remember, anytime we see bullet points like this, usually it's going to set up like an if scenario. Not so much here. This is more like we have to write a method in part B that kind of just walks through this step by step. So this might turn out to be like 4 lines of code or something else. We'll figure that out. But each one of these bullets is probably going to translate to like a line of code or 2 lines of code as we go through. And then there's a little trick. As you go across the board, you reach the end and you have to roll back to the 0. Anytime you see a rollover with integers, consider using a modulus. That's usually the easiest way to do it. You can also write an if statement to roll back to 0. So whatever you're more comfortable with. Maybe the if statement's easier for you. Okay. And then let's look here. This I think is the first problem we've seen. Okay, and this is a trend now. I think from here going forward, we'll see this on every test. But 2013 was the first one that I remember seeing where students had to write the code of a constructor. Okay, it may have happened in like one of those case study problems from an earlier year, but this is the first one we've done together that has you write a constructor. And that's important because constructors have some different rules. How do I know this is a constructor? Well, it's got the same name as the class, token pass, and there's no return type. You never return from a constructor, ever. Okay, so just never write the word return in a constructor. A constructor's job, and this is crucial, is to initialize all of the instance fields. When they say creates a board, that doesn't maybe sound like, Java speak, but it really is. So they're telling you that you got to create the board. Remember, board has only been declared at this point, right? Private int array board, that's declaring the existence of an integer array. That integer array has not yet been created. So that's the very first thing I would probably do in my answer, like just so I don't forget later. Before anything else, I think I would write board equals new int player count, because to me, like, that's job one. I can't use that array. I can't mention board in any context until I've actually created an integer array and assigned it to board. We haven't done that in any problem previous to this one, but because we haven't written a constructor yet. Okay? Constructors play by different rules, right? And so this constructor, we're trying to initialize that array so that we can use it throughout the problem. Now it's a valid storage device. You go back and look at all the older problems we did. Every array and array list we've handled so far, there's been a little note on it that said was initialized in the constructor, meaning they did it for us. This time it fell on us, and that was our job. We had to initialize the array, okay? Now I've got to do a couple of random values. So there's 2 different things going on here. I have to go to every space on the board and put in a random number of chips, okay? So, for example, I could say like int I equals 0. I'll walk across the board length. You could also use player count here. It should be the same thing. So board length, I++, okay? And everybody gets a random number of chips ranging from 1 to 10 as an integer, okay? So, I mean, I hope you could write this line of code in your sleep. by now, but if not, there it is. Okay, that's going to give me a random int from 1 to 10. All right, now there was another instance field here, current player, and we need to initialize current player as well. And you could have done this before or after the for loop. I can't see why it would matter. Okay, and this is also a randomly generated int. I'm not going to put a +1 on this one because I actually want 0 to be a possibility, and I'm going to multiply it by player count. Now, it's like, I think they almost did this as like a trick, right? But I don't put a -1 on there. If I want it to go inclusively from 0 to player count -1, I actually multiply by player count. So if there's 5 players, if I multiply by 5, I'm going to get a random int 0, 1, 2, 3, or 4. So every one of those 5 players has a 20% chance of being picked, basically. Okay. So that -1, I know it's a little confusing. They threw that in there, but you got to know your random numbers. And again, this line of code could have gone above the for loop. Okay, it doesn't really matter. But yeah, okay, so that should be our board being constructed now. Now we have to create the gameplay. Okay, so like here's an example of a game board. It had 5 players, and everybody got a spot. I set it up a little randomly too, so the boards being generated in part A could have anywhere from 2 to 6 players. So if you ran this again, you might see a smaller board or a larger board, and then everybody should have a random number from 1 to 10 within that board. Okay, so if you ever saw like a 0 or an 11 or something, then something didn't go right. Okay, but yeah, all right, looks like it's working in part A. All right, now what happens is you've got your current player. Okay, so your current player, all of their tokens get picked up off of the board, and then they start to get redistributed. And the rules for redistributing them are the player to their right gets 1, the player to the right of them gets 1, and you keep going in this pattern until you run out of tokens. You may end up giving some back to yourself or whoever that current player is. You can't step off the board. Once there's no more tokens to distribute, then the turn's over. Notice how this board has 5, 6, 10, 21 tokens in it. You better end up with 21 tokens when you're done. Okay, they don't disappear. So we take 6 away from this player, but then we redistribute all 6 of those tokens by the end of our turn. So there's going to be 21 tokens on the board still. They're just going to be in different places. And we see that here, 5, 3, 1, 12. That still adds up to 21. Okay. So again, we want to walk through those exact actions. So for example, I might just say something like int tokens equals, I'm going to go to the board, and I'm going to go to the board at current player. Okay, so notice that one of the post conditions here says that current player has not changed. So you got to be a little careful. I could see students writing in an answer where they add to current player, like they might do current player plus plus to move across the board. You really don't want to do that because we want to make sure that we leave current player alone. So don't do anything that's going to change that current player. Now, I could see writing a for loop here. It'd be a little tricky because if you wrote a for loop, you might consider the for loop walking across the array, like with indexes, but that's not really the control of this problem. The control is when we run out of tokens to distribute, okay? Right? This is going to keep happening while there's tokens left to distribute. So for me, I think writing a while loop makes the most sense. Now, like I said, I need a way to move across the array, the board, but I don't want to mess with current player, which is the index that I'm currently located at on the board. So you might want to maybe, I don't know, make like a copy of current player. You might even want to go ahead and add 1 to it right now, although it doesn't really matter. You could do that prior in the loop or at the end. But if you did it now, I guess the advantage is now when you go to the board, you would go to that index, okay? and you would add one token to it. So like you could do like a plus plus. You could also do a, you know, a plus equals one, or board index equals board index plus one, whatever, it doesn't really matter. You'd want to move over on the board, okay? So you need an index plus plus. That's different than saying board index gets bigger. And we gave away one of the tokens, so I'm going to put a minus minus on my tokens variable. If I keep giving away tokens, eventually I won't have any left to give away. Now, there's really just one thing I didn't consider yet. If I keep moving across this board, I'm going to go off of it. I'm going to go out of bounds. So again, this is where you could use a modulus to your advantage here. If you did a modulus of board.length, every time it went to step off of that board, we would divide by the board length. That's, if you think about it, like if the board length is 4, it's indexed 0, 1, 2, 3. So as soon as you hit index 4, that's going to divide by 4, no remainder. It's going to roll back right to 0. And then it's just going to start over again. It's going to go 0, 1, 2, 3. Once it hits 4, it's going to roll back to 0. So that's why I was saying, like, using the modulus is kind of a nice little trick here. And so this should just keep us in bounds. We keep moving across the board, and we keep giving away tokens, and eventually we should run out. This is all randomized, so you're going to have to kind of check your own code in part B. Okay, so like I said, you'll just have to kind of look at the board and sort of figure it out. Replic's giving me some issues today, so I think this is what happens when you have 4 kids and they're all on the Wi-Fi at the same time, but let's see. Try it again. All right, so randomly selected player value 0 through, okay, so I got current player 3. That's this 7 here. Oh, you know what? I'm sorry, I forgot one step. Oh, I would have got an 8 out of 9 this year. How embarrassing. All right, once I took those tokens away, oh, everybody can point at me and laugh. I don't see you, so it won't hurt my feelings. But feel free. I should have set their token count to 0, right? So once we take the tokens from a person, oh, I feel so embarrassed. We need to set them to 0. I could edit that out of the video, but I'm going to leave it in there so that you guys see me make a mistake and you can, you know, feel good about yourselves and laugh at me. All right, so this one, we only took 2 tokens away from player 1. One of those tokens went to player 2 and one went to player 3. So let's run another one so that we can see if our rollover strategy is working or not. Well, it barely worked here. Okay, so we took 2 tokens away from player 3. One went to player 4, and then it did roll back to player 0. See that 4 went to 5. Let's see if we can get like a bigger number of tokens to be redistributed. No, that wasn't a good one. Let's try one more maybe. I'd like to see one where we take like a lot of tokens away from a player. Okay, so this time from player 3, we took 8 tokens. So this is a little more interesting. Okay, so 1 token went to 4, 1 to 5. It rolled back 0, 1, 2, 3. We still had 2 more. So notice one of the tokens actually made it back to the current player. That's correct. These 2 players each picked up 2. And then, so that's a total of 4. The other 4 tokens ended up over here. So 2, 5, 5, 8, 3, 6, 6, 1, because 8 became 0 and then rolled down to 1. So yeah, this looks like it's working perfectly. I mean, you know, could you do a for loop here? Yeah, but again, it'd be a little weird because a for loop to me, you'd be walking across indexes up the board while the control is handed to the tokens. I don't really like it, but you know, if you want to try one, go for it.